Welcome to our today's mathematics class, where we are going to continue with our algebra on the introduction to formal algebra. Now, just before we proceed, I want us to remind ourselves what we went through in our last class, especially the terms that are used in the algebra. Now, first, we needed to know that algebra is simply an expression which actually forms what we call algebraic expression. So, algebraic expression is simply an expression like this that follows. So this one here is an algebraic expression, as we had seen it in our previous class. The other thing we need to know is these letters that we have, the unknown letters that we have. These ones are called pronumerals. They are called pronumerals. Pronumerals are the letters that are used in an expression. Now, there is also need to know that when we have x and y, in most cases, they stand for certain numbers. It could be 1, it could be 2, depending on the situation. So, since the values of x and y keep on changing, we can also call them variables. You can also call them variables. So you can say in this particular case, x and y are variables. Now, when we have the pronumerals like a multiplied by b, it can also be written as simply a b. And if we have a divided by b, this one can be written as a over b. So we can simply express the two in that particular manner. Now we have what we call a term. Now, when you talk about terms, simply here, we are trying to talk of an expression which consists of both numbers and pronumerals. A term is simply consisting of both pronumerals and numbers. And we can sometimes have them combined. Like this one here, we have got three terms. X is a term, y is a term, and also the constant 3 is also a term. So we have three terms here. But also the terms can be combined. When we say combined, we can have them like 2x plus xy plus 4. So in this case, you realize that 2 and x have been combined, but it forms a term. X and y also forms another term, and 4 also forms a term. So terms can be combined. Now, when we talk about the algebraic expression, now algebraic expression here, it simply consists of various terms that are combined together. Now we can have the pronumerals, we can also have the numbers, but when they are combined together and then with the signs of addition and subtraction and so on, they'll simply form what we call an expression. So algebraic expression is simply a combination of both terms and pronumerals. Now, as we look at a good example, I can have an expression like 2x plus 4y plus 6. This is an algebraic expression. It has got three terms, 2x, 4y, and 6. Now, these three terms that we have, again, we shall realize that there are some numbers that come before the pronumerals. These numbers that come before the pronumerals, we call them coefficients. We call them coefficients. So coefficient of x here is 2. Coefficient of y here is 4. And when we have a number without a pronumeral and without also any other letter, we shall call that number a constant. So we have this one are terms. The number before a pronumeral is a coefficient, and when we don't have any number without pronumeral, we say this one is a constant. So taking, for example, identify the number of terms, the pronumerals, in the coefficients, and the constant in the following. 8x plus 2y plus z. This is an algebraic expression. This algebraic expression has got various terms. Now, we want to identify the terms. We then identify the coefficients and the constant. To start with the terms in this expression are 3, and they are those which are combined with pronumerals and others that are just a constant. We have 8x, 2y, and 2. For the coefficient, it is a number that comes before the pronumeral. And in this case, we have x, and before x, we have 8. So one of the coefficients of x is 8. Therefore, the coefficient of y is 2, the number that comes before a pronumeral. And finally, if we have a number without a pronumeral, then that number will be referred to as a constant. And in this particular case, the number that we have is 2. So let us look at a few examples that apply the knowledge of algebra. First, when we look at the terminologies used in algebra, the question may read, this question is a question on terminologies of algebra, and it's asking us to list the individual terms in the expression 3a plus b plus 13c. So this particular case, we only need to identify the terms that exist. And the terms here, the terms are, we have 3a. We also have another term here as b. And the last term that we have in this expression is 13c. So these are the terms that form the algebraic expression that we have right here. The next question that we need to look at is a question that touches on how we can simply write expressions from the word descriptions. This is a question where we are going to expect to have an expression formed from word description. And the word description here is write an expression for the 5 more than k. 5 more than k. Then it means that the numeral that we have is a k, but the expression we require should be 5 more than k. So this one will give us k plus 5 as our expression. Now let us now look at expressions involving more than one operation. So we shall look at different questions independently and one at a time. Remember, we want to express the situation when we have more than one operation. Now, the question says, write an expression for each of the following without using multiplication sign or the division sign. The symbols that we are supposed to avoid are those. So the question is, P is halved, then 4 is added. P is halved, then 4 is added. So remember, we are supposed to avoid multiplication sign or division. So we have the solution here. We shall have P is halved, which means when it's halved, it is divided by 2. But we've been told to avoid a multiplication symbol or a division symbol, which means that we shall not write it this way, but instead we shall halve it by putting P over 2. Then 4 is added. So the results of P over 2, we shall add 4. So this forms the expression. It forms the expression of P being halved, then 4 added. That's what we have. In another question, so the second question that we have here is this. The sum of x and y is taken and then divided by 7. The sum of x and y is taken and then divided by 7. Now, the pronumerals we have is x and y. So in our solution, we need to identify the x and y. So when we talk about the sum of x and y, it is the same as x plus y. That's what we have. Now, if the sum of x and y is taken and then divided by 7, it means we can have this in bracket, and then we need to divide by 7. But since we are to avoid this symbol of division, then this expression will be rewritten as x plus y, the whole of it over 7. So we have simply expressed, given an expression for the sum of x and y, and then the sum is simply divided by 7. The next question is asking us to give an expression for the sum of x and 1/7 of y. Sum of x and 1/7 of y. Pronumerals we have is x and y. But before we take the sum, we need to know what about y. It is 1/7 of y. So y has a coefficient which is 1/7. So we shall have our expression here being x added to 1/7 of y, which is simply 1/7 of y. And this one can simply be written as x plus 1/7 y. It can also be written as x plus y over 7. So you realize that we have shown that it is the sum of x and 1/7 of y, or it can be just x added to y over 7. The last one we have 5 is subtracted from k and the result is tripled. 5 is subtracted from k and the result is tripled. This particular case, we want to subtract 5 from k, which implies we shall have k minus 5. So this one, it means 5 is subtracted from k. And then the results, which means the results is what we have inside the bracket, is tripled. When you say it is tripled, it is simply multiplied by 3. Now the sign multiplication symbol is supposed to be avoided. So we shall have it as k minus 5 into bracket 3. K minus 5 into bracket 3. Or it can be 3 into bracket k minus 5. Still we see that it is simply 3. There is tripling the results of k minus 5. So we must be able to simply read a statement and form an expression, whether we are to use the symbols or not. Let us not take note that the operations could be we could either have one operation or multiple operations, depending on how the statement reads. Let us further look at other areas where we apply algebra. Now, in this, match each of the word descriptions on the left with the correct mathematical expressions on the right. So on the left side, we have the word descriptions, and on the right, we have expressions. First one is the sum of x and 4. 4 less than x as our second word description. The third one, the product of 4 and x. 1/4 of x, the results from subtracting x from 4. And finally, 4 divided by x. On the side where we have the expressions, we have x minus 4, x over 4, 4 minus x, we have 4x x over 4 over x, and finally x plus 4. 4 over x and x plus 4. Now, let us start. We want to match and see what it means. The sum of x and y. In this particular case, I expect you to give us the sum of x and y. So we shall look at 4. We shall look for an expression here which has x plus 4. This one means the sum of x and 4. So when you look at this, you find that this one here is the right expression for that. So I'll simply indicate that is where the expression is. The second expression, the second word description is 4 less than x. 4 less than x. What does it mean? 4 less than x. It means this 4 is being subtracted from x. That's why we say 4 less than x, not x less than 4. So 4 less than x, we expect it to be an x minus 4. This is 4 less than x. So in this particular case, you realize that the expression that matches this one is with this one here, so I'll simply match it like that. The third one is the product of 4 and x. The product of 4 and x, as we saw earlier on, it means that it is 4 multiplied by x. And when you say 4 times x is the same as 4x. So I look for an expression which is like this, 4x. And when you look at it, 4x is here, so this one matches that. 1/4 of x. 1/4 is the same as 1/4 of x, which is x over 4. So we are going to look for a term there which is the same as x over 4. And x over 4 here is here, so we shall match this one here to the term that we have there, which is x over 4. So results from subtracting x from 4. Note this. This is the expression we are looking for. Results from subtracting x from what? From 4. So that means that we have 4 subtract the x. So this is the result obtained when we subtract x from 4. So when you look at an expression which looks like this one here, it is right here. So we shall match this one here with the expression that we have there. The last one, which you even do not need to do it, but look at the unmarked fields and you match it. And we already have this one as the field that is not touched. But otherwise, it says 4 divided by x. 4 divided by x is simply 4 over x. So we shall look for an expression which is 4 over x, and you'll find that the match is right there. So it is very important, a learner, to use the word description, interpret it correctly, and form an expression which clearly describes the wordings. If you have your expression, then you have simply simplified the long many words into simple mathematical expression. Now, this time now, we are not going to match expressions, but we are going to form expressions independently without looking at the options that we have. So in this, write an expression for each of the following without using a multiplication symbol or a division symbol. A, 5 is added to x, then the results is doubled. B, A is tripled, then 4 is added. The third one, K is multiplied by 8, then 3 is subtracted. So we are interested in now forming a mathematical algebraic expression from the word problems that we have. Unlike what we covered earlier, where we had the options where we were to choose which expression matches the word problem. So in this particular case, it is us to form. So from the first one, 5 is added to x. So what comes first is x, we add to 5, and then the result is doubled. So you'll find that this one here, we shall have it as simply x add to 5. When you add x to 5, the results, you introduce the bracket, is doubled. So remember, I don't need to use the symbol of multiplication. That's why I am avoiding it. So it can be x plus 5 into bracket multiplied by 2. That same statement means 5 is added to x and the result is doubled. There is nothing wrong, however, if someone will write 2 into bracket x plus 5. There is nothing wrong. You can have it either x plus 5 in bracket 2 or 2 into x plus 5. It means that that is the expression for the word description that we have looked at. The second one, A is tripled. Then 4 is added. When we talk of A being tripled, we are looking at A multiplied by 3. That is what being tripled means. So in this particular case, if A is tripled, then we have 3A. And then what happens? This A is tripled, then 4 is added. So from 3A, we shall come and add 4. This will give us the results. This will give us the result of the word description of A being tripled, then 4 is added. That is 3A plus 4. For the last one, we have K is multiplied by 8, then 3 is subtracted. K is multiplied by 8, then 3 is subtracted. So if somebody was to take it logically, you would just say that K is multiplied by 8. You will be wrong because we don't need to use the sign of multiplication. So K times 8 is the same as 8K. So I'll expect you to have the product of K and 8, that is K is multiplied by 8, as 8K. Then we find that 3 is subtracted. So from 8K, we move ahead and subtract 3. So the expression is ready. We have 8K minus 3, or 8K subtract 3, which is the same as the word problem that we have above. Now, in our normal daily life situation, like when we are doing measurement and we are measuring distance, we are looking at either kilometers or meters or centimeters. Same way, we can find expression to express distances or other measurement or lengths of various shapes. So let us look at some problems that touches now on a real life situation where we do the measurements in meters or centimeters. Now, I'll summarize the question, but before that, I'll only write down, but I want us to put in mind the following. That we all know that what we should note, 100 100 centimeters is equivalent to 1 meter, and 1,000 meters is equivalent to 1 kilometer. 100 centimeters is 1 meter, and 1,000 meters is 1 kilometer. Now, let us look at the question, putting in mind the knowledge that we have above. So from the knowledge of relating kilometers, meters, and centimeters, question asks us to write an expression for each of the following. How many meters are there in X kilometers? How many centimeters are there in X meters? And finally, how many centimeters are there in X kilometers? From the first one, how many meters are there in X kilometers? Now, this one, we simply look at it. We find that if we are to relate the first one, we find that from here, we saw that 100 meters is equivalent to 1 kilometer. But what we want to find out is how many meters are there in X kilometers. So in this particular case, it will mean it is X multiplied by 100 divided by 1 kilometer, which is simply X kilometers multiplied by 100 meters divided by what we have here is 1 kilometer. Now, kilometer here and this will go. So we have X multiplied by 100, which will give us 100X. And the answer is in meters. So the number of meters that will make X kilometers is the number of let's use a bigger space here. Now, the relationship between meters and kilometers, kilometers and meters is given as 1,000 meters equivalent to 1 kilometer. So if 1,000 meters is equals to 1 kilometer, then it will mean that 1 kilometer is 1,000 meters. How about X kilometers? This one will be simply X multiplied by 1,000 divided by 1. X multiplied by 1,000 divided by 1. It will give us 1,000X. And kilometer will cancel, we shall remain with meters. So we find that X kilometers is equivalent to 1,000X meters. The second question, how many centimeters are there in X meters? how many centimeters are there in x meters. Again here, we look at the relationship between the centimeters and the meters. The relationship between centimeters and meters is given here. 100 centimeters is equals to 1 meter. If that is the case, from that we see that if at all we have 1 meter equals to 100 centimeters, then we find that x meters will be equivalent to what? X meters will be equivalent to x multiplied by 100 over 1, and the answer we have here is in centimeters, which is simply 100x centimeters. So we have our answer or our expression that 100x centimeters is equivalent to x meters. For the last one, how many centimeters are there in x kilometers? Now, this one requires us to apply quite a number of knowledge, and we shall look at it that the relation, we need to come up and develop a relationship between the centimeters and the kilometers. And for us to get this relationship, we must have developed the relationship between the centimeters and meters. So we find that 1 meter is equals to 100 centimeters. 1 kilometer is equals to 1,000 meters. So, if we want this, we should find out first by changing the kilometer into meters. So it means that if we don't want to use here, we shall bring in and say then that also this, if 1,000 is the same as 1 kilometer, then we need to find out how many centimeters makes 1 kilometer. So that one will be equivalent to saying that 1,000 meters is equivalent to how many centimeters? So when you say 1 meter is 100 centimeters, how about 1,000 meters? For 1,000 meters here, which is equivalent to 1 kilometer, it will be simply that 1,000 meters to get into centimeters will be multiplied. So we shall find that 1,000 meters is equivalent to 1,000 times 100. So 1,000 meters, which is equivalent to 1 kilometer, is equals to 1,000 multiplied by 100, which gives us 1, 2, 3, 4, 5. It gives us 100,000 centimeters. 100,000 centimeters. This is the same as 1 kilometer. Now that we have 1 kilometer represented in form of centimeters, then we come to the question, how about x kilometers? For x kilometers, it will be simply 100,000 multiplied by x divided by 1. So it will be 100,000 times x divided by 1, which is the same. So it will be 100,000 x centimeters. So x kilometers is equivalent to 100,000 x centimeters. So in this question, as we've looked at, and the expression itself, you'll find that there is need for us to understand what is the main purpose of expressing our word description in algebraic expressions. Why do we need to bring in mathematical expressions in a long sentence of in a long sentence of wordings. Now, I want you to look at this phrase, and then you see what exactly happens. Twice the value of the sum of x. Twice the value of the sum of x and 5. We have seen quite a number of problems touching on this. Now, when you look at this, it is a whole sentence of so many words. But when you bring it in algebraic expression, then you'll find that putting it mathematically, it is reduced. And you find that it is very, very simple for a student to just now come and say that this is what? The sum of x and 5. And the sum of x and 5 is x plus 5. That is the sum of x and 5. Twice the value of. So twice the value of this sum of x and 5. So you'll have the bracket and put a 2. Now look at this. If you were to use the wordings, you'd have written 1, 2, 3, 4, 5, 6, 7, 8 or so wordings to express a very simple expression, which when come mathematically, you can just say that it is 2 into bracket x plus 5. So algebraic expression in our life situation has simplified word problems that we can simply give expressions very brief, unlike when we are to represent a whole statement. Now, sometimes we have a situation where we use wordings and pronumerals when dealing with life situation of purchasing items and so on. I want us to look at the following question. Looking at this question, the question says, Michaela is paid X dollars per hour at her job. Then the question, how much does Michaela earn when she works for 8 hours? How much does Michaela earn when she works for 8 hours? Now, we need to relate the number of hours and the rate at which she is paid per hour. So in this question, she is paid 1 hour, she earns X dollars. So if she works for 8 hours, it will mean that she'll earn 8 multiplied by X divided by 1, which is equivalent to 8X dollars. 8X dollars. So we are able to find what Michaela earns simply by taking the product of X, which is the rate per hour, and the number of hours. And remember, a pronumeral is a letter which can represent any value. So if we had Michaela earning a certain value, for example, if we had been given like X is a certain value, if we were to be given like $3, that X, it is $3 per hour. Now, then it means that this X, is equivalent to $3. So we shall not say she earns $3x. Sorry, she earns $8x. But instead, we shall substitute X with the rate that we have been given 3 per hour and find that finally she'll earn 8 multiplied by 3. So this 3 per hour comes in as a substitution, where now if you want to find the real rate which she'll earn, it will be 8 multiplied by the 3, which gives us in dollars 24. So this is how algebraic expressions can be expressed in our real life situation, maybe at work and other places. I hope you have enjoyed the lesson. Thank you.